Alright, today we're going to look at zeros of a polynomial, and we're looking for all the zeros now, including complex. The fundamental theorem of algebra says that every polynomial whose degree is greater than 0 has at least one 0 in the complex number system. Keep in mind that this is thinking of your real numbers that can also be considered complex, because if you have a solution of 2, it could be considered 2 plus 0i. So every polynomial is going to have a complex solution, is what that is saying, as long as it's not a constant. So let's verify that we can have complex solutions. We're going to start with that, just plugging in I and seeing if it would give us a complex answer, or give us a 0. So I'm going to plug in I, because I'm telling you that these could be zeros, and let's see what happens. I to the 4th minus I to the 3rd minus 5 times I squared minus I minus 6. So I to the 4th is 1. I to the 3rd would be a negative I, so that's going to be plus I. Negative 5 times I squared would end up being a negative 5, so it's going to be plus 5. Minus I minus 6. So if I put that together, those cancel, that's 6 minus 6, which is 0. So yes, I does work. It is a 0 for that. Now let's try negative I. So negative I is equal to negative I to the 4th minus I to the 3rd, negative I to the 3rd, minus 5I squared, negative I squared, minus negative I minus 6. Sometimes what I like to do with the negative I is just take care of it first, treat it like a negative x, and think about how it would affect the equation that I'm plugging it in. Negative I to the 4th would just still be an I. If I have a negative and I'm cubing it, that's going to end up giving me a plus. So it's going to be plus I to the 3rd. I'll take care of the i's in a minute. I squared, if I plug a negative in there, that's not going to change it, so it's going to be minus 5. I squared. And then a negative I minus a negative I is going to end up being plus I for that one, and then minus 6. So now I can go and just evaluate the i's, just like we did on the previous problem. So I to the 4th is 1. I to the 3rd is minus I, negative I. This is going to be plus 5, because I squared is a negative 1. Then we have plus I minus 6. So if I add that up, i's cancel, 6 minus 6 is 0. So yes, it also is a 0. This is just showing you the theorem that's below here. The complex conjugate zero theorem says that if you have a complex 0 like I, its conjugate, negative I, is also a 0. So formally, looking at this theorem, if a polynomial p of x has real coefficients, and if a plus bi is a 0, then we know its conjugate, a minus bi, is also a 0. So when we have zeros that are complex, they always come in pairs. All right, so now we're going to look at using this to factor. So on this problem, I'm telling you that I is a 0. So we know that I is a 0, which means we also know negative I is a 0. So the factors that would give us those solutions are x minus I and x plus I. Because we want to find the other factors, we need to divide our polynomial by this. But to do that, we want to multiply it together, so we're not dividing by a product. So this is going to be x squared minus ix plus ix, then plus 1, because I times I is I squared. squared. I squared is a negative 1, and we're going to minus a negative 1. So now we're going to use long division to find our other, or the rest of our polynomial, once we remove these factors. And I'm factoring it by x squared plus 1. So how many times does x squared go into x to the 4th? X squared times x to the 4th minus x squared. Subtracting this, and we're subtracting that whole thing. Those cancel. This is minus x to the 3rd. And then minus here would be negative 5 minus 1x, so it's a negative 6 x squared. How many times does x squared go into negative x to the 3rd? It goes in negative x times. So that is negative x to the 3rd minus x. So that's subtracting this whole thing. Those cancel. And a negative 6x squared that comes out. These cancel. And a negative 6. So how many times does x squared do that? Negative 6 times. Negative 6x squared minus 6. Subtract those and I get 0, which is good because I showed it as a factor. So I have x squared minus x minus 6. That is my other polynomial. I can easily factor this with the rules that I learned in Algebra 1 and Algebra 2. So this would be x minus 3 and x plus 2. And then I already had my factors earlier right here. There's those factors, and now I have these, so I have all of them. So what are my factors? X minus I, x plus I, x minus 3, and x plus 2. That's all of them. All right, we're going to try another problem, a little more complicated. All right, so the second example, we're told that we have some complex zeros. And, well, we're told 1, x equals 1 plus I, which means we also know that we have x equals 1 minus I, because remember, they come in pairs. So what are our factors then? Factors from these. One of our factors will be x minus this. So x minus 1 plus I is one factor. And the other factor is x minus that. So x minus 1 minus I is the other factor. Now, we need to multiply those together. Remember, we need to find our product, so then we can do long division. This product would be kind of messy. I mean, we could do it, but I'd rather change these around a little bit. Makes it just a little bit easier. So I'm going to distribute that negative, and then I'm going to, oh, that's a 1. Then we're going to regroup that together. And I'm going to do the same thing over here. Distribute the negative, and then regroup this. Makes it easier for me to multiply. So now I'm going to multiply these two together, so I get x minus 1 squared, because those were the same, I could do that. My middle terms are going to go away, because we have negative I times x minus 1 plus I times x minus 1, so those cancel out. And then I have a negative I times a positive I, and that's going to be plus 1. Now, of course, I still got to keep going. I've got to go ahead and expand that. That is x squared minus 2x plus 1, but then I also have this other plus 1, which means that it's x squared minus 2x plus 2. So that's what I'm going to divide by, so then you find my other factors. Remember that I already have these two factors. I'm looking to see if I have any more. So I'm going to do some long division here with my original, which is x to the 4th minus 2x to the 3rd plus x squared plus 2x minus 2. And I'm dividing that by x squared minus 2x plus 2. So x to the 4th divided by x squared is x squared. X to the 4th minus 2x to the third plus 2x squared. So then I'm going to subtract those, subtract the whole thing, subtract that whole thing. That cancels, and I'm left with a negative 1x squared. Now because I'm dividing by two things, I need to bring these two things down. So how many times is x squared going to negative x squared? It's going to go negative 1. So that's going to be negative 1x squared plus 2x minus 2. I'm going to subtract that. That cancels, that cancels, that cancels, equals 0. So my other factor, my other polynomial is x squared minus 1, which I can factor into x plus 1 and x minus 1. And then I have the other two from above, so I have 4 factors altogether. I have those two, and then I also have x minus 1 plus I, and x minus 1 minus I. There we go, there's my 4 factors. Now, that's with me giving you the complex. We're going to look at now doing the whole thing. But before we start that, we have to think about how many zeros we'll have. So the number of zeros is equal to the degree of the polynomial. So we talked about how complex have to come in pairs, so we're going to look at this problem. We're going to do 2 of them, just coming up with how many of each we should have or be looking for. So looking at A, we have a degree of 5, which means we have 5 zeros. We will have exactly 5 zeros. It's not like last class where we said that we can't have more than that. Now, because we're looking at the complex, we will find all 5 of them. So our complex, because we have 5 at most, they come in pairs. So we could have 4, because that's 2 pairs, or 2, or 0. So thinking about the real numbers, if you had 4 complex, you'd have 1 real. If you had 2 complex, you'd have 3 real. And if you had 0 complex, you'd have 5 real. So then we're going to look at the rule of signs. Looking at the rule of signs at the original problem, which I'm just going to do above here, I see 1, 2, 3 sign changes. So we can have 3 or 1. So we have 3 or 1. Looking at negative, I'm going to plug in. That's going to make negative 17x to the 5th plus 2x to the 4th plus 3x to the 3rd plus x squared minus 5. So I see 1, 2. So 2 or 0. So we could have 2 or 0, 2 or 0. So I know I have a total of 5. So if I look at the first one, I have 3 and 2. That's 5 already. So I have 0 complex. Looking at the second one, I have 3 and 0. So I could have 2 complex. Looking at that third one, I have 1 and 2. So that's 3. So I could have 2 complex. And then looking at the last one, I have 1 positive, 0 negative. So that means I could have 4 complex. So this is my options for what I could have. And let's take a look at another example, and we'll see when we do the problem below, this all comes together to help us factor. So this has a degree of 4, so its number 0 is a 4. So complex, we can have 4, 2, or 0, which means we would have 0 real if we had 4 complex, 2 real if we had 2 complex, and 4 real if we had 0 complex. So using our rule of signs, we have 1, 2 sign changes. So for the positive, we have 2 or 0. 2 or 0. Now let's look at the negative. If I plug in a negative x, I get 5x to the 4th minus 2x to the 3rd plus x plus 2. So I have 1, 2 sign changes, which means I have 2 or 0 negative. Those are my positives. So I could have 2 and 2, 2 and 0. I could have 0 and 2, 0 and 0. And then I can determine how many complex. If I have 2 and 2, then I have 0 complex. If I have 2 and 0, then I have 2 complex. So I've got to have a total of 4. If I have 0 and 2, then I have 2 complex. And if I have 0 and 0, then I have 4 complex. So once we make that chart, we know what we should be looking for. So now we're going to put everything together. Here's problem, just as fast. So first thing I'm thinking about is my degree. My degree is 5. That means I need to have 5 zeros. So my zeros are going to be 5. So just me thinking in my head. That means if I have complex zeros, I can have 4, 2, or 0. 4, 2, or 0. Those are my options. So using the rule of signs, I see one sign change. So for my positive x, I have one positive. That's it. There's just one. So positive, I have one option. 1. Let's see what I have for my negatives. I get a negative x. I get a negative x to the 5th plus 2x to the 4th plus x minus 2. Looking at sign changes, I have 1, 2. So I could have 2 or 0 negative. So I could have 2 or 0. Now knowing that it's a 5th degree, if I have 1 and 2, so 3, if I have 3 real, then that means I have 2 complex. And if I have 1 or 0, that means I have 4 complex. So now we're going to look at what could we have, what are possible real ones. And that's using the our rational zeros factors of the n, -2, which is plus or minus 1, plus or minus 2. And then factors of 1, plus or minus 1. So their quotient would give me plus or minus 1, plus or minus 2. So those are the numbers I need to test. And I am going to test it. I'm not going to worry about using the bound rule because I don't have that many. If I plug in a 1, I get 0. I plug that in to the original function. If I plug in a -1, I get 0. If I plug in a 2, I get 60. And if I plug in a -2, I get 0. So I have 3 right there. I have -1, -2, and 1. So that means I'm in this. I'm 1 positive and 2 negatives. So I have 2 complex. So to find those complex, I need to come up with my factors. Oops. X plus 1, x plus 2, and x minus 1, which I'm going to put these two together. Now I need to multiply these together. When I multiply those, I get x squared minus 1. I have to take that as x plus 2. That's going to be x to the 3rd plus 2x squared minus 1x minus 2. Now I can use division to come up with my other factor. So my original problem, way up here, you can't see it, x to the 5th plus 2x to the 4th plus 0x to the 3rd plus 0x squared minus x minus 2. Make sure about that minus 2, double check it. And I'm dividing by x to the 3rd plus 2x squared minus 1x minus 2. So how many times does that go in there? X squared. That's x to the 5th. 2x to the 4th plus minus x to the 3rd, and then minus 2x squared. I'm subtracting this, which cancels that one, cancels that one, makes this x to the 3rd, and makes this one plus 2x squared. Then I need to bring down the rest, because I have 4 to divide by. So then when I divide, that's going to be plus 1. And when I subtract these, everything cancels, and that's 0. So that's my other factor, x squared plus 1. Now, I have two factors, or three factors already. I have these ones. Now I can get more, two more, because I need to have a total of 5 from that. And I said 2 of them had to be complex. That's going to be these ones. It's going to be x plus I and x minus I. Because if you solve that, that's what you would get. And then I have x plus 1, x minus 1, and x plus 2. So my solutions are negative I